Alright, so today's question is 199 binary tree right side view. We are given a binary tree. Imagine that we are standing on the right side of it. Return the values of the nodes that we can see from top to bottom. As an example, we have a tree with 1, the left children is 2, right children is 3, and the right children to 2 is 5, the right children to 3 is 4. Because we are standing on the right hand side of the tree, the nodes that we can see is 1, 3, and 4. The node with value 3 is going to block the nodes with value 2. The nodes with value 4 is going to block this 5 if we are standing on the right hand side. So basically what this question is asking is for each of the levels of the tree, we want to return the value of the rightmost nodes in that level. So 1 is the only node here, so the value is 1. 3 is the rightmost nodes in this first level, in the second level here, and the node 4 is the rightmost node in the third level. So to solve this, we can do first search BFS, and for each level we just return we just append the node value, the value of the node that's to the rightmost location. So it's a pretty straightforward question. The time complexity for this question is just order of n. That's the number of nodes in the tree. And the space complexity is, in the worst case, is the number of nodes in the very last level, because that's potentially the one with the time that the queue can accumulate the most elements in it. So that, because it's a binary tree, the largest possible number of nodes in the very last level is n. The number of nodes in the whole tree divided by 2. That's the maximum possible value. So because it's a constant multiplied by n, asymptotically it's order of n. So it's linear in time and linear in space with respect to the number of nodes here. So that's the pretty much the strategy, doing BFS level by level, and we just collect the value of the rightmost node for each level. So let's code this question up really quickly. There is nothing said in the question about whether we can get a garbage in, so just to safeguard the program. If we have garbage in, we throw nothing, and we'll keep track of the current level we're looking at, which initially to be 0, and the queue is initialized with only the root node in there. And the stuff that we put on the queue is going to be a tuple with the node, reference to the node element, and the level. So root and let's call it 1 actually. So the result is going to be an empty array in the beginning. While we still have nodes that we should explore, we pop the node out of the queue. Node level is equal to queue.popleft. So if the node has a level that's higher than the current one, we're gonna basically put that onto our result. So what do we need to return? Do we need to return the reference of the node or the node value? So based on the annotation here, it's a list of integers, not a list of node objects. So it's we should append the node value. And since Since the node value is larger than the current value, meaning that we are starting to explore the next level, we're gonna increment the current level counter here. And since that the first node we see in the level is gonna do this append and increment of the level counter, so for the children's we need to always put the rightmost first. So we basically, for the children's of children's from the previous layer, we're gonna put the rightmost first. We're gonna do that from right towards the left. So this is what I'm talking about. The order of nodes that we explore in the next level is the from the rightmost towards the leftmost. That's guaranteed by this by the way that we are putting the nodes of the next level onto the queue. So in the end, we should just return the result array. And let's check if there's any obvious errors here. That's the edge case with nothing coming in. So this current level counter is initialized to be 0. When we first see the root here, the root node's value is going to be appended to the result here. And the way that we explore the next level is always to explore the right one first. And yeah, it all seems good to me. So let's this is there any problem? No, there's no problem. The increment by 1 is fine, because when we increment 1, the nodes that are on the same level will never trigger this line, so it should be fine. Okay, let's submit this. Okay, it's working. Alright, so that's the question for today.